Difference between synchronous and induction motor. Differences. A synchronous electric motor is an AC motor in which, at steady state, the rotation of the shaft is synchronized with the frequency of the supply current. An induction or asynchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. Synchronous motor operates at RPM equals 120 f/p. Induction motor operates at less than synchronous speed, RPM equals 120 f/p, slip. Synchronous motors require DC excitation to be supplied to the rotor windings. Induction motors don't require DC excitation to be supplied to the rotor windings. Synchronous motors require a DC power source for the rotor excitation. Induction motors don't require a DC power source for the rotor excitation. Synchronous motors require slip rings and brushes to supply rotor excitation. Induction motors don't require slip rings, but some induction motors have them for soft starting or speed control. Synchronous motors require rotor windings. Induction motors are most often constructed conduction bars in the rotor that are shorted together at the ends to form a squirrel cage. Synchronous motors require a starting mechanism in addition to the mode of operation that is in effect once they reach synchronous speed. Three-phase induction motors can start by simply applying power, but single-phase motors require an additional starting circuit. The power factor of a synchronous motor can be adjusted to be lagging, unity or leading. Induction motors must always operate with a lagging power factor. Synchronous motors are generally more efficient than induction motors. Induction motors are generally less efficient than synchronous motors. Synchronous motors can be constructed with permanent magnets in the rotor eliminating the slip rings, rotor windings, and DC excitation system and power factor adjustability. Induction motors contain slip. Synchronous motors are usually built only in sizes larger than about 1,750 kilowatts, because of their cost and complexity. However, permanent magnet synchronous motors and electronically controlled permanent synchronous motors called brushless DC motors are available in smaller sizes. Smaller induction motors are built and commonly in household applications. Synchronous motors are used in timing applications such as in synchronous clocks, timers in appliances, tape recorders, and precision servo mechanisms. Three-phase squirrel cage induction motors are widely used in industrial drives because they are rugged, reliable, and economical. Induction motors are used extensively for smaller loads, such as household appliances like fans.